Acha. So today we're going to start with prism. My first question is, what is prism? See, prism is nothing but geometrically transparent medium that is used to refract light. That means it will be shaped somewhat like this, okay, triangular prism. Suppose I'm talking about triangular prism. A triangular prism would be made up of a triangle, okay. It's a shape like this, where a ray of light means any ray of light comes from this side, goes into the prism and comes out of the other side. Okay, so these kind of devices where the light goes in from one side and comes out from the other side is called prism. Okay, so in our curriculum we deal specifically with the prism that is shaped in this kind of manner, or a triangular prism. Okay, okay. So even in triangular prism, okay, suppose the material, this prism is made up of any material. Suppose a glass made up of refractive index mu. Okay, so this prism will refract the light. So study the properties of incoming rays and outgoing rays for this prism. Okay, and so in our prism, we study our prism mostly in this manner, or this is of the prism. Okay, let this be a triangular prism of triangle ABC. Okay. A ray of light is coming on face AB. Okay, now out here, this is the normal on the face AB. This incident ray of light will refract in the prism, but this is the angle of incidence I1, this is the angle of reflection R1. Okay. And as soon as it reaches the second surface, this surface, it will again try to refract back into the AM. No? So on this surface AC, the normal is given by this line, and while escaping, the ray of light escapes something like this. So out here, let us name this angle as R2 and this angle as E. Okay. Now our point in studying the prism was finding out the relation between various angles, irrespective of the angle of I or E. Means whatever be the angle of I or whatever be the angle of E, I have to find the relation between this I, R1, R2, E. And there is one more special angle we have to consider, is the angle of prism. What is the angle of prism? This is the angle of prism. The angle opposite to the base of the prism. Okay, how do you consider which is the base of the prism? See, this surface refracts one light, this surface another reflection happens. So the surface in which no reflection happens is called the base of the prism, and the angle opposite to the base of the prism is the prism angle. So this is nothing but the prism angle. Prism angle. This is nothing but the incident angle. Incident angle. This out here is nothing but the emergence angle. Emergent angle. Okay, there is one more specifically angle we need to learn is something called angle of deviation. Angle of deviation means the angle by which the incident vector is the reflect incident vector is turned to the reflected vector. That means it's the incident ray of light, right? This out here is the incident ray of light. If you extend this incident ray of light vector, it goes somewhat around this. My question is, by what angle should I turn this incident ray of light vector so that it becomes emergent ray of light? So to find that angle, what do we do? We even trace back the emergent ray, and out here, this angle is called the angle of deviation, or the angle by which the incident ray must be bent or rotated so that it forms the reflected ray or refracted ray vector is called the angle of deviation. This out here is the angle of deviation. Now, in an entire study of prism, okay, what you are going to specifically study is the relation between this I, A, R1, R2, angle of deviation, and B. But that's it. And sometimes refractive index of the prism. Okay, so let us relate my first equation. So the first equation that I must know is A is equals to R1 plus R2. Okay, very good. But my question is, how did I derive this relation? A is equals to R1 plus R2. That means this angle is equals to this angle plus this angle. Okay. Okay. What we are going to do also is we are going to prove the relation A is equals to, or angle of prism is equals to R1 plus R2. But this angle is equal to this angle plus this angle. So how do we prove that? See, we extend our line out here. Okay, we extend this line. Now let this angle be C. Now look at this quadrilateral. A is the quadrilateral. Okay, inside this quadrilateral, this line and this line of triangle, this line is normal to this plane of prism. No? So let us say this angle be 90. Even out here, this line is also 90 degree or normal to this line or this plane of prism. So let us say also this angle to be 90 degree. Okay. Now can I say the angles of quadrilateral have to be 360 degrees? So can I say angle A plus 90 plus angle C plus 90 is equals to 360 degrees? So formula number one or equation number one, A plus 90 plus C plus 90 is equals to 360. Okay, because angles of a quadrilateral are to be 360 degrees. Now from here you can get A plus C is equals to 360 minus 180 is equals to 180. Okay. Now look at this triangle. This triangle also. Okay. Can I say C plus R1 plus R2 is equals to 180 degree, because angles of a triangle are to be 180 degree. C plus R1 plus R2 is equals to 180 degree. Okay. Now, okay. Now can I compare this one? This one. A is equals to 180 minus C. Or out here, R1 plus R2 is equals to 180 minus C. See, out here A is also 180 minus C. Out here R1 also is equals to 180 minus C. So comparing this two equation, comparing this equation and this equation, can I say A is equals to R1 plus R2? So therefore, comparing equation 1 and 2, comparing equation 1 and 2, we get A, or angle of prism, is equals to R1 plus R2. This is our first line of proof. So this is our first theorem, the first formula that we are going to learn in prism or triangular prism. Now what we are going to learn is the second rule of prism, or second relation between the angles of prism. A plus D is equals to E plus I. Okay, A plus D is equals to E plus I. Or angle of prism plus angle of deviation is equals to angle of emergence plus angle of incidence. A plus D is equals to E plus I. The best way to remember is going in alphabetical order. A, B, C, D, E, F, G, H, I. And there is a equals to in between. Okay. Now in this slide we are going to prove the relation that we have just written down. Okay. Derivation of A plus D is equals to E plus I. Okay. So to derive this relation, okay, the prerequisite or the first thing that we must know is A is equals to R1 plus R2. That is as derived in the previous slide. Okay. Now using that derivation, What is this angle? This entire angle. This entire angle is nothing but I. Why? This angle and this angle are same. Similarly, this angle and this entire angle is E. This entire angle is E. Very good. Now, how much is this much angle only? See, if this entire angle is I and if this angle is R1, this much angle is nothing but I minus R1. So this much angle is I minus R1. Okay. And similarly out here, if this entire angle is E and this much angle is R2, so this much angle, okay, is nothing but E minus R2. So this much angle is nothing but E minus R2. Okay. Now see this triangle. This triangle. See this triangle. In this triangle, I minus R1, this angle plus this angle is equals to 180. Let this be angle X. Okay. So can I say from the triangle I minus R1 plus E minus R2. This angle is I minus R1, this angle is E minus R2 plus X. Plus X is equals to 180 degree. Plus X is equals to 180 degree. And see after. This is a straight line. Okay. So X plus D is the nothing angle between this incident vector and emergent vector. So X plus D is nothing but 180 degree. So X plus D, X plus angle of deviation is equals to 180 degree. Okay. So if I send this to the right hand side, this is A, this is equation B. So or D is equals to 180 minus X. From equation 1, I minus R1 plus E minus R2 is equals to 180 minus X. Okay. Now if you compare this equation and this equation, 180 minus X is equals to D, 180 minus X is equals to I minus R1 plus E minus R2. So can I say D is equals to I minus R1 plus E minus R2? So by comparing A and B, by comparing A and B, okay, D is equals to I minus R1 plus E minus R2. Okay, or D is equals to I plus E minus of R1, R2. I took the minus common. Now what is R1 plus R2? R1 plus R2 is nothing but A as derived in the previous slide. So I can simply say angle of deviation is equals to I plus E minus A. Or if you take the A to the left hand side, D plus A is equals to I plus E. This is our second derivation or second rules of second relation between angles of a prism. Now what we're going to study is the condition for minimum angle of deviation. Condition for minimum angle of deviation. So what are you trying to achieve out here is a prism. Okay, this is A, this is B, this is C. And the ray of light goes out here. The ray of light will come inside the prism and the ray of light will go out. And this is our angle of deviation. This is our angle of deviation. My question out here is for what values of for what values of I, for what values of I we get minimum value of D. minimum value of D, or angle of deviation. So the condition out here is when I is equals to E, okay, or when the angle of incidence is equals to angle of emergence, okay, when angle of incidence means this angle of incidence is equals to angle of emergence, okay, we get minimum value of deviation. We get minimum value of deviation. Okay, so when I is equals to E, we get minimum value of deviation. The second criteria of I is equals to E is nothing but when the ray inside the prism is parallel to the surface BC. Okay, for minimum angle of deviation, this ray becomes parallel to the surface BC. So the ray inside the prism, the ray inside the prism becomes parallel to surface, parallel to base surface, parallel to base surface. Okay, but this surface is called base. Okay, now I understood that when I is equal. Now I understood that when I is equals to E, that means this I is equals to E, we get minimum angle of deviation. But what is the exact value of I? Okay, so what is the value of I in terms of Piston angle? Because this Piston angle or this angle A would be constant, no? Because this A is dependent upon the design of the prism. Okay, so from angles of prism, we do know the angle formula. A plus D is equals to I plus C. So for minimum value of D, for minimum deviation, I is equals to E. So in this formula, can we write A plus D is equals to 2I? Okay, and what is D minimum? D minimum, or angle of deviation minimum, is equals to 2I minus A. We send this A to the right hand side, or D minimum is equals to 2I minus A. Okay, and few more things to remember out here is, see, at minimum angle of deviation, this ray is parallel to the base. I is equals to E. The value of D minimum is equals to 2 into I minus A, or twice of angle of incidence minus A. One more thing, note out here. R1 is equals to R2. Why? If I is equals to E, then R1 is also equals to R2, no? Because out here, if we apply Snell's law across this surface, 1 into sine I, or sine of A, sorry, refractive index of A is 1 into mu sine of R1. And if we apply Snell's law out here across this surface, okay, mu into sine R2 is equals to sine mu. We know that I is equals to E. When I is equals to E, R1 is also equals to R2. Okay, when R1 is equals to R2, okay, and we know A angle of prism is equals to R1 plus R2. Okay, let this R1 plus R2 be R is equals to R, or A is equals to R1 plus R2 is equals to 2 of R. Okay, let R1 be R, R2 be R. So angle of prism is equals to 2R. Okay, so A is equals to 2R. If we substitute A is equals to 2R out here, we get angle of prism is equals to, or D minimum is equals to 2I minus 2R. 2I minus 2R. Or D minimum is equals to D minimum is equals to 2I minus 2R. Okay, or D minimum is equals to 2 into I minus R. Now my question is, what is the relation between I and R? The relation between I and R is given by Snell's law. Sin I is equals to mu sin R1, or sin I is equals to mu sin R. Okay, so always remember where where sin I is equals to mu sin R. Now you can substitute any relation that is given in the question according to your convenience. But always remember three fundamental facts. For minimum angle of deviation, I is equals to E, D minimum is equals to 2 into I minus R, okay, and R1 plus R2 is equals to R, where A is equals to 2R. So these are the four things you must remember. And A is equals to 2R. Okay, out here from A is equals to 2R, can I find the angle of incidence? See, A is equals to 2R, or A is equals to 2R. Okay, or R is equals to A by 2. Can I say sine A by 2 is equals to sine R? Okay, sine A by 2 is equals to sine R. Okay, can I add mu both sides? Mu. Okay, if I add mu both sides, mu into sine R is nothing but sine I. So out here, can I say mu sine A by 2 is equals to sine I? Okay, this is also one of the relation for minimum angle of deviation. Okay. Now what you're going to study is the condition of no emergence. Okay. Condition of no emergence. What is this condition of no emergence? See, suppose this is a prism out here. This is a prism out here. Okay. I'm interested in what is the angle or what is the maximum value of angle A, so that all the ray, or what is the minimum value of A, so that all the ray totally internally reflects out here. Okay, this is the surface, this is I, this is R1, this is R2, this is E. My condition is, what is the minimum value of A, so that all the ray totally internally reflects out here. Okay, so can I say A is equals to R1 plus R2? Okay, or R2 is equals to A minus R1. See, from here we can safely say, if we keep the value of R2 minimum, then you have to keep the value of R1 to be maximum. Okay, so to keep the value of R2 minimum, we must keep the value of R1 maximum. Okay, why are you trying to keep the value of R2 minimum? To avoid total internal reflection across the surface. So you are trying to avoid total internal reflection in this surface by keeping R2 minimum. Okay, now to keep R1 maximum, I should be maximum. Why? Because sin I is equals to mu sin R1, where mu is the refractive index of the glass. So if I increases, R1 increases. So what is the maximum value of I possible? the maximum value of I possible is nothing but 90 degree. Okay, so maximum value of I possible is nothing but 90 degree. So this is prism angle. Achha. Let's draw this triangle little bit good. Okay. Okay. Maximum value is 90 degree. Assume this ray to be 90 degree. This is 90 degree. So after refraction into the prism, okay, this R1, by applying Snell's law, can I say I1 into sine 90 is equals to mu into sine R1? And where have you seen this one? You have seen this relation in critical angle. So can I safely say that R1 is equals to critical angle? Critical angle. Why? Because remember the equation of critical angle. In the equation of critical angle, what used to happen? This was the denser medium. Suppose this was the medium of prism. This was air. Okay. And what is to happen? Incident ray at critical angle is to do grazing ray of incidence. Okay. Now if you invert this one, or if you oppose the direction of it, it would come like this. So simply this is air of refractive index 1. So I simply said sine 90 is equals to mu sine of theta c. Okay. Now does this equation look like this equation? So if this equation looks like this equation, can I say R1 is equals to critical angle? Of course I can say R1 is equals to critical angle. Okay. Now this ray out here reaches this surface. Okay. Now I must keep the R2 to be minimum. No, this R2 should be minimum. Okay. So at this minimum R2, okay, this R2 minimum should also be greater than the critical angle of this prism, because the critical angle of this prism is dependent upon mu and refractive index of the air out here. Okay. Okay. Now from here, what can I say? R2 minimum is equals to A minus R1, or out here I can say that R2 minimum is equals to A minus R1 maximum. Why? Because to keep R2 minimum, we must keep R1 maximum. And what is the value of R1 max? What is the value of R1 max? When angle of incidence is max, and R1 max is nothing but critical angle. See, R1 is maximum when incident ray is maximum. And when is the incident ray maximum? At 90 degree. And if you make this equation, we get maximum value of R1 possible is nothing but the critical angle in this between these two medium. Okay, so R1 max, therefore R1 max is nothing but critical angle. Theta c is nothing but critical angle. Okay, so R2 mean should be greater than critical angle. Why? Because at this junction, the minimum value of R2 should be greater than critical angle so that it can pass through. Okay, and now what is the value of R2 mean? The value of R2 mean is nothing but A minus R1 max, or A minus R1 max is greater than equals to theta c, is greater than equals to theta c. Achha. And now what is the value of R1 max? The value of R1 max is nothing but also theta c. So R1 max is also theta c, or critical angle. So A minus theta c is greater than equals to theta c, or critical angle, or A is greater than equals to twice of critical angle. So can I say to design a prism, okay, to design a prism, in order to avoid total internal reflection, the prism angle must be greater than twice of critical angle, or prism angle, this angle must be greater than twice of critical angle. Well, if you understood this one, now my question is, what happens if A is lesser than twice of critical angle? If A is lesser than twice of critical angle, no ray will pass through this surface. Then for all angle of incidence, be it 0 or 90, all the rays out here will be totally internally reflected across this surface. Okay, so write out here, note, if A is lesser than twice of critical angle, then no ray can emerge out from the prism. No ray for any angle of incidence. For any angle of incidence, any angle of incidence can emerge out of the prism, can emerge out of the prism, or can emerge out from this surface. Okay, now what you're going to study is angle of deviation for thin prism. Okay, angle of deviation for thin prism. Thin prism. What do I mean by out here is, suppose there is a thin prism out here. Okay, for thin prism there will be small values of A. That means thin prism means small values of prism angle. Prism angle A. So for small values of prism angle A, the values of R1 and R2 would also be small. Okay. So when values of R1 plus R2 or R1 and R2 is also small, can I apply the relation that I derived earlier, where A plus D is equals to I plus C? Okay. So for prism angle, what happens is, see, can I apply Snell's law across I and D? This is nothing but I. Okay, and this is nothing but E. This is angle I, this is angle E. So can I write 1 sine I is equals to mu sine R1 and mu sine R2 is equals to sine E. Now see, now there is a mathematical concept. Okay, for very small angles, for very small angles of theta, this theta should be in radians. Okay, for radians. Okay, for very small angle in theta, that means if theta is very small, theta can be approximated as sine theta, which can be approximated as tan theta. So this is a mathematical theorem that we'll use out here. Okay, so for very small angles of theta can be approximated as sine theta, which can be approximated as tan theta. Okay, now see out here, this R1 is small, R2 is also small, so sin I is also small. So sin I can be approximated as I into mu. Sin R1 can be approximated as R1 out here. E can be approximated as mu into R2. Why? Because sin E can be approximated as E and sin R2 can be approximated as R2. Now if we substitute this value, if you substitute the value of I and D out here in this equation, what do you get? A plus D is equals to mu R1 plus mu R2, or A plus D is equals to mu R1 plus R2. Now what is R1 plus R2? R1 plus R2 is nothing but A, or A plus D is equals to mu into A, or D is equals to mu A minus A, or D is equals to mu into, or sorry, A into mu minus 1, A into mu minus 1. So irrespective of the angle of incidence or angle of emergence, the deviation or angle of deviation for a thin prism is nothing but prism, angle of prism into mu minus 1, refractive index minus 1. Okay, So this is the condition for thin angle, or angle of deviation for a thin prism. So angle for deviation for a thin prism is nothing but prism angle into mu minus 1. Okay, so let's start with the question. Okay, the question says, find the value of angle of emergence of the prism if the refractive index of the glass is. So out here, refractive index of this glass is root 3. Now see, this ray of light comes out here straight. So what is the value of R1 out here? The value of R1 out here is equals to 0. Why? Because angle of incidence is equals to 0. So sine of 0 is equals to mu into sine of R. So sine of R is also 0. Now what is the angle of this prism? Angle of this prism is nothing but 60 plus 30 plus 90 is equals to 180 degree, because angles of a triangle is equals to 180 degree. Now since we know that R1 plus R2 should be equals to A, R1 plus R2, R1 plus R2 should be equals to A. So they directly know that R2 is equals to 30 degree. Okay, and therefore angle of emergence can be found out using Snell's law, where root 3 into sine of 30 is equals to 1 into sine of p. Sine of 30 is nothing but 1 by 2, or root 3 by 2 is equals to sine of e, and which value of e gives sine root 3 by 2 is nothing but e is equals to 60 degree, because sine 60 is equals to root 3 by 2. Let's proceed to the next question. The refractive index of a material of a prism is root 2 and the angle of prism is 30 degree. Okay, let's draw the diagram. This is a prism. The angle of the prism is 30 degree. The refractive index of the prism is root 2. Okay, one of the two refracting surface of the prism is made up of mirror inwards by silver coating. That means, let's say this surface is nothing but a mirror with inward coating. Okay, a beam of monochromatic light entering the prism from the other face will retrace its path. That means there is a beam of light, okay, out here. It will retrace its path. That means out here, this incident ray after reflection will follow the same path. And when does that happen? When there is normal ray of incidence out here. Normal ray of incidence means the angle of incidence out here, angle of incidence is 0. So angle of reflection will also be 0. So if angle of reflection is 0, the incident ray will follow back its normal ray path. Okay. Now this out here is the value of R1. See, out here if the angle of incidence is 0, okay, the value of R1, or the value of angle between the ray and the normal of this side is nothing but 0. So therefore R1, or sorry, R2 is equals to 0. So we know that R1 plus R2 is equals to prism angle, and R2 is equals to 0. Why? Because normal incidence. Okay, out here the mirror has normal incidence, or angle of incidence is equals to 0. So therefore R2 is equals to 0. So therefore from this one we know that R1 is equals to 30. Okay, now we need to find out the value of I. So you can simply write sine of I is equals to mu sine of R1, or sine of I. What is the value of mu? Root 2. Sine of R1, sine of 30. And what is sine of 30? 1 by 2. See, 2 can be written as root 2 into root 2. So sine I is equals to this 2, and this root 2 will get cut. So 1 by root 2. Therefore I is equals to 45 degree. So I is equals to 45 degree. Okay, let's proceed to the next question. The angle of prism is A. One of its refracting surface is silvered. If the light rays falling on the angle of incidence is 2A on the first surface, returns back through the same path after suffering reflection at the silver surface, the refractive index of the prism is. That means there is a prism. okay, of prism angle A. Out here one of the surface is silver. From here a ray of light is incidence. What is the angle of incidence? The angle of incidence is 2A. Okay, and this ray of light collides normally. Why does it collide normally? Because the incident ray retraces back the reflected ray. So out here R2 is equals to 0. Find the value of mu such that this one. So what is this value R1? The value of R1 is nothing but A. Why? Because R1 plus R2 is equals to A. So can I apply Snell's law across this surface? Can I apply Snell's law across this surface? Can I write sine of 2A is equals to mu into sine of R1 or sine of A? Now from trigonometry, there is a relation. Sine of 2 theta is equals to 2 sine theta into cos theta. This is a trigonometric relation. Okay. Now if we apply this trigonometric relation in our equation, we get that sine 2A becomes 2 sine A cos A is equals to mu into sine A. This sine A and this sine A gets cancelled, or cos A is equals to mu by 2. Okay, or mu is equals to 2 of cos A, or mu is equals to 2 of cos A. Okay, so the correct answer is they have asked the refractive index, mu is equals to 2 cos A. Okay, let's read the next question. The refractive index of the material of prism is √2 and its refracting angle is 30. One of the refracting surface of the prism is made inwards. The beam of light, monochromatic ray of light entering the prism from one face will retrace its path after reflection from the mirror surface. If the angle of prism is, I just solved it little bit earlier. The answer is nothing but A. Okay, see out here. I'm solving this fast because I just solved it afterwards. Means sometimes before. 30. Mu is equals to √2. Out here, this surface is mirrored. So out here, this is E. So R2, this angle is 30. So I, sine of I is equals to √2 into sine of 30, or I is equals to 45. I just now solved it before. Okay, let's go to the next question. Look out here. The angle of incidence for a ray of light at a refracting surface of a prism is 45. So there is a prism. Okay, the angle of incidence is 45. The angle of prism is 60. This angle is 60. If the ray suffers minimum deviation through the prism, okay, the angle of minimum deviation and the refractive index of the material of the prism are respectively. This for minimum deviation, there are two conditions. First one is this ray should be parallel to the base. Okay, and the second condition is I is equals to E. The value of R1 equals to R2. Okay, the value of R1 and R2 is equal. Okay, we also know that R1 is equals to R2, R1 is equals to R2, and R1 plus R2 is equals to A. Okay, so from equal to R, or R1 plus R2, or R plus R is equals to 60, or R is equals to 30. This is 30 degree, this is 30 degree. Okay, this one is R1, this one is R2, and R1 is equals to R2. Why? Because I is equals to E. Now can I apply Snell's law across this surface? Okay, if I apply Snell's law across this surface, sine 45 or sine I is equals to mu. Mu is the refractive index of the prism into sine 30. Okay, or sine 45 is 1 by √2 is equals to mu. Sine 30 is 1 by 2. Okay, or mu is equals to √2. So the angle of minimum deviation, acha, mu is equals to √2. So option number C and D is cancelled. Okay, Now they are asking the angle of minimum deviation. Acha, for minimum deviation, can I apply I plus E is equals to A plus D? For minimum deviation, I is equals to E, or 45 is equals to 45, or I plus E is equals to 90 is equals to, what is A? The value of A is nothing but, the value of A is 60 plus D, or D is equals to 30 from this equation. So option number A is our correct equation. Now let's read the question. The refracting angle of a prism is A, and the refractive index of the material of the prism is cot A by 2. The angle of minimum deviation is. Out here, there is a prism. Okay. Now for minimum deviation, what is the condition? This ray is parallel to the base, and I is equals to E. So can I say I plus E is equals to A plus D? This is the one of the relation we arrived before. For D minimum, I is equals to E, or 2I. Why? Because I is equals to E, so I plus I is equals to 2I is equals to A plus D, or I is equals to A plus D minimum divided by 2. D minimum divided by 2. Now if we apply Snell's law out here, okay, we know that I is equals to E, and this R1 is also equals to this R2. So R1 plus R2 is equals to A. So this is nothing but A by 2, and this is also nothing but A by 2, no? So this is A by 2, this is also A by 2. Now can I apply Snell's law across this surface with refractive index of the prism is equals to mu? So can I say sine of I is equals to mu into sine of R, where sine of I is nothing but, what is the value of I? A plus D minimum by 2. So sine of A plus D minimum by 2 is equals to mu into sine of R. Mu into sine of I is equals to mu into sine of R. What is the value of R? A by 2. Sine of A by 2. Or mu is equals to sine into A plus D minimum by 2 divided by sine of A by 2. Okay, now this is one of the standard formula that you have to remember. Okay. First remember all those formulas that I have taught you out there, then come to this formula to remember this formula. Okay. Okay. Now U is given as cot A by 2. So mu is cot A by 2. Achha. What is cot A by 2? Cot A by 2 is nothing but cos A by 2 divided by sin A by 2. Cos A by 2 divided by sin A by 2. And what is the value of mu? The value of mu is nothing but sin A plus D minimum by 2 divided by sin A by 2. Or is equals to sin A plus D minimum by 2 divided by sin A by 2. Okay, sin A by 2 and sin A by 2 gets cancelled. Okay. Now the angle for minimum deviation is, okay, can I say cos A by 2 is nothing but sine of 90 minus A by 2. This cos A by 2 is nothing but sine of 90 minus A by 2. Sine of 90 minus any angle is equals to cos of that angle is equals to sine of A plus D minimum, or angle of deviation minimum, by 2. From this two relation, can I say 90 minus A by 2 is equals to A plus D minimum by 2? Okay. or 90 minus a by 2 is equals to a plus d minimum by 2, or 180 minus a by 2 is equals to a plus d minimum by 2. 2 and 2 get cut cancelled, or d minimum is equals to 180 minus 2a is equals to d minimum. So 180 minus 2a is equals to d minimum. Okay. See out here. The refractive index of the material of prism is √3. Then the angle of minimum deviation of the prism is, see, whenever, okay, whenever, suppose, let's see what it is given. Out here this prism is given, the refractive index is equals to √3. For minimum deviation, this is the case. Okay. Now whenever the prism angle is not given, okay, assume for NEET level question, assume the prism angle or the prism to be equilateral prism, or every angle of the prism is 60 degree. Okay, so out here is nothing but this is 30, this is 30. Okay, and I is nothing but, see, sine I is equals to √3 sine 30, or sine I is equals to √3 into what is sine 30, 1 by 2, or I is equals to 60 degree, or I is equals to 60 degree. Now what is the value of deviation? I can simply use a plus d is equals to I plus e. Okay, or a plus d is equals to 2i, or what is the value of a? 60. What is the value of d? We have to find it out. What is the value of I? 60, and 2i is nothing but 60 into 2, 120. D out here is nothing but 120 minus 60 is nothing but 60. Option number C. Achha. The angle of deviation by a prism. Okay, for angle of prism A to be small, we have directly derived this. Deviation is nothing but d into u minus 1 into A. For small prism angle, angle of deviation is equals to refractive index minus 1 into prism angle. So let's read the question. Okay, a ray is incident and the angle of incidence I on one surface of a prism angle and emergent normally from the opposite surface. Okay, this ray, okay, is incident on I. Okay, and it emerges normally. Normally means out here. This prism angle is out here. What? Sorry, out here. This prism angle is 90 degree. It emerges normally. Okay, so out here R2 is equals to 0. So this R1 value, R1 is equals to A. Why? Because R2 plus R1 is equals to 90 degree. Okay. Now, see, if the refractive index of the prism material is mu, that means can I apply Snell's law in this surface? So let this be I. So sin I is equals to mu sin A. For very small angles, sin I is equals to I, which is equals to, and sin A is equals to A. Why? Because these are small angle prisms. So therefore the angle of incidence is nearly equals to mu into A. We use a mathematical theorem for very small angles, for very, I have already derived this, or I have already said this theorem. For very small angle, theta, theta can be approximated as sine theta, which can be approximated as tan theta, and theta should be taken in radians, not in degrees. Okay. Okay. This is the same question as before that has been asked previously. So the 2020 questions have been repeated from 2012. Okay.